Hello data scientist, welcome to Skillgate. In this course, we will build and deploy a sentiment analysis project end-to-end in its truest sense. There are hardly any videos on YouTube that show you the entire sentiment analysis journey of formulating a problem, training ML model, deploying ML model, and then testing it in a live environment. We shall use sklearn pipeline for this project, which is a low-code magical way of building models. Alright then, let's get started. For introductions, we are Skillgate and we are on a mission to bring you application-based machine learning education. We launch new machine learning projects every month, so make sure to subscribe to our channel to get access to all of our free projects. You may contact us via email or WhatsApp in case you need any ML project related help or to simply discuss your crazy ideas. We have already done this basic sentiment analysis project where we used bag of words representation for input data and naive-Bayes estimator for binary classification. If you are just beginning your ML journey, I'll strongly recommend you to go through this project as well. Link to this is in the description part below. Alright, that was a quick introduction. Coming to the problem in hand now, let's start off with some basics. sklearn pipeline is a major productivity tool to collapse all pre-processing and modeling steps into a single line of code. In layman terms, sklearn pipeline is like a factory where sequential transformation operations are performed on input data, followed by a single sklearn estimator. And the pipeline has methods fit, predict, and score just like any other estimator for producing outputs. So vaguely, if the input data is text, component A of our pipeline, which is the series of transformers, shall transform this data to numeric representation like this. Then component B shall fit a model on this training data and then make predictions on the unseen data. The way we serialize a trained model as a PKL file or pickle file for later use, over here we shall directly serialize the pipeline as a pickle file. Isn't that cool? It is for sure. To know more on pipeline, refer to the link provided in the description part below. Alright, now let's formulate a sentiment analysis problem. Amazon Alexa product reviews data is a popular publicly available dataset of customer reviews. This is what it looks like. We have 5 columns. First one is the rating on a scale of 1 to 5. Second is the date of review, then the product variant details, followed by review text and review sentiment. In this project for us, the important columns here would be verified review text and the rating. Alright, we are ready to jump into the coding part now. As is the case with any Skillgate project, I hereby present to you our free Skillgate do-it-yourself toolkit for you to try out this project yourself. Link to this toolkit is in the description part below. Over here we have this dataset file and this Python source code file. We also have this additional data cleaning Python script, which we shall talk about in a minute. For now, let's open this source code to train our sklearn pipeline based sentiment analysis model. So this is our source code Jupyter notebook on Google Colab. As per our plan, we first load our Alexa reviews dataset from Google Drive. Then we generate positive negative labels using review ratings. Then we use TF-IDF vectorizer, a popular feature engineering technique to convert our text review data to numeric representation. Then we use support vector classifier for model training, and at last we use our model for predictions on unseen data. All right, let's do a quick code review now to understand what this code does. Over here, first up, we are importing our essential libraries. Then we are connecting to Drive. Post that, we are setting our working directory. Then we load our dataset from our Google Drive folder, essentially our toolkit. This looks familiar, right? We have the same 5 columns as we discussed. And in this data, this first column rating and this fourth column verified reviews is what is of interest to us. Post that, we create a data frame called dataset, where we keep only the 2 data columns of our interest, verified reviews and rating. We also rename them with a cleaner looking header text. Here we go. Next up, we define this function to generate binary labels from the rating, which is on a scale of 1 to 5. So all reviews with rating over 3, we say positive, and reviews with rating less than or equal to 3, we say negative. Then we call this function that we just defined on all the rows under sentiment and get the labels. We can also look at the changes that have happened. As you may see, now we have ones and zeros as compared to these numbers on a scale of 1 to 5. We can also do a count of our sentiments across positives and negatives. So as we can see, a great deal of our reviews are positive reviews. So because we are talking about Amazon Alexa product, which is sort of a popular product, so this makes sense. Then we can also check for null values if there are any. As we can see, there are none. So on this factor, we are good. So now we come to the important part of data transformation. Over here, first up, we define our X and Y. Then we import custom tokenizer example from the tokenizer input code file. So it's a custom sort of script that we have written, and if you remember, it's the same script that we had lying here in our toolkit, right? So let me sort of run this. I'll quickly give you an overview of what the script is. What does it do essentially? So this is the code that we have written underneath the script. So tokenizer input is a separate Python script with which we are tokenizing our reviews data. Over here, this is the custom tokenizer class we are importing into our main code file. Within this, we are first importing popular NLP library called Spacey. Within Spacey, we are loading this Encore WebSM package. This package basically helps in breaking down sentences into its components. We also download stop words and punctuation marks. So basically, it's a dump that we are downloading for both these things. Later, within this custom tokenizer class, we define this method text data cleaning, wherein we perform lemmatization on the sentence tokens. We also drop all tokens that are stop words or punctuation marks. Finally, the method returns the cleaned list of tokens. So if I quickly explain this with an example, let's say the review that we are passing to this tokenizer is I love Alexa, right? So this, whenever this text data cleaning method is called on this sentence, I love Alexa, first of all, this NLP function will break down the sentence into its components. So in case of I love Alexa, we get three components: I love and Alexa. Later, for all these components, we run a loop, and for every component we check if the component is a pronoun. If it is, then we take it as is, otherwise we convert it to its lemma form. Then we store the partially clean tokens here in this list, and then for all of these we check for stop words and punctuation marks. If the clean tokens, if the partially clean tokens are neither present in stop words nor are punctuation mark, then we append them to this clean tokens list again, and then this list is returned back, right? So with this, now we have a good understanding of what our tokenizer does. So now let's see it in action. So over here, as you can see, we are calling this custom tokenizer example, and within this we are calling this method text data cleaning on this sentence, which is those were the best days of my life, right? It's a line from a popular song. Over here, as you can see, all the components are converted to a lowercase, and majority of the more than half of the components here are dropped because they are either a stem word or it's a punctuation mark, right? So with this we get a clean form of the sentence, and we only get the sort of words that carry some meaning, right, for a review being positive or negative. So with this custom tokenizer, we shall get tokens for every sentence we feed in, but we also need a way to convert those tokens to a numeric representation. For this, we are using the popular TF-IDF vectorizer. As you can see, within TF-IDF, we are using our custom tokenizer the way we just discussed. So long story short, tokenizer returns the select tokens from review text, and vectorizer converts review text into a numeric tabular form. I'll provide you with a reference link on TF-IDF vectorizer to strengthen your understanding further on this. Then we prepare for model training by splitting data into 80-20 training and test. We also stratify this split across the sentiment positive negative, because we want the distribution of the data across training and test to happen uniformly with positive negative sentiments. All right. We may also check the count of sample we have across training and test. Now comes the interesting part where we fit our sentiment analysis model pipeline to the training data. For this, we first import the pipeline and SVC estimator from sklearn. Then we define our pipeline. As I explained previously, sklearn pipeline is basically a series of transformers glued to a final estimator. In our case, we have a single transformer, the one we defined here, and then we have our classifier, the one we defined here, right? With this, we are all set. Let's fit our sentiment analysis pipeline on the training data. Here we go. All right, we are done. Now for predictions on the test set, we use the pipeline method predict to generate labels on the unseen data. Post that, we'll plot a confusion matrix to know how our model performs on unseen data. As you may see, we are getting around 91% accuracy, right? Now for model serialization, as we serialize a model file as PKL, Similar to that, we can also serialize a pipeline as a pickle file. So that's what we are sort of trying to do here. So once we do it, and if you go back to the toolkit, you will see the pickle file getting generated. It's here. All right, now when we have our model pickle with us, we are all set to deploy it. But before that, let's have some fun with our newly trained sentiment analysis pipeline. So there are a couple of ways sort of we are trying to do it. One is the simple way, like we have, we are feeding the a typical review to the pipeline, and we are calling predict method on it. And then if prediction is positive, then we print this, and if the prediction is negative, we print this. Now let's try to see what we get. We see that Alexa is bad, as a review is a negative review as predicted by our model, and it's rightly so, right? And similarly, if I change bad to good, so then it looks like a positive review, and let's see what our model says. The model also says that it's a positive review, so this way we are good. Now I've also written this second leg of script wherein we are doing this entire prediction in a more sophisticated way, wherein we are running a loop, and the user is asked to input as many Alexa product reviews as he or she sort of intend to insert, and on all of those reviews, sort of predictions are returned by the model. I was actually intending to you to try it out yourself, but I think it's better if we sort of have the fun now itself. Now, for example, we have this. So I say Alexa is good. So we get our first result. This is positive. And then I can say Alexa is negative. Let's see what we get on this. It says, oops, no. Alexa is bad, not negative. So on that I get negative. And for closing this loop, for breaking this loop, I just need to type skip. And once I do that, I am out of the loop. Right. And another interesting thing we are trying to do with this one is that we are actually compiling all these interactions that you just had with the model and recording them back into the toolkit. So once I run this line of code, so the sort of script compiles the entire interaction in this form, and this data is stored as a CSV back into the toolkit, as you can see here, right? So there are use cases for this wherein we want all the logs to be sort of returned back into the system so that we can keep a track as to what happened. Now, because we were in the same Jupyter notebook, that's why we were able to sort of, use this pipeline for predictions without, loading the pickle file. But if we are, intending to use this same sentiment analysis model on a different notebook or in a different machine, then you may have to load this pickle file first up, and then you can use it for your predictions. So this is the exact same thing we will do when we get into the deployment part of this project, which we are going to discuss next anyway. So now when we are done with developing our sentiment analysis model using sklearn pipeline, next step is to deploy this model using Flask and try it out in a live environment. That part I'm covering in a separate video, link to which is in the description part below. Among machine learning professionals, development is considered to be the trickiest affair, and there are thousands of crazy memes around model deployment. These are the few I leave you with to excite you further to join me in for the second part of this sentiment analysis project. To get regular updates on our ML projects, do subscribe to our channel and recommend us to your friends as well, so they may also benefit from our work. Thank you for all your support. Keep learning. Bye.